sharing my screen also. I hope you can see the screen and I'm audible.
Yes, sir, you're audible.
Okay, all right. So in the last class, I think we were okay. Let me upload this thing also. And then people can join. Upload. Okay, I am done with the sharing of slides and all. So what we were doing in the last class, let us quickly recap it. So we started with the introduction part. So who are you and what is that exactly you work and who am I and my experience and that profile has helped us to, you know, like understand each other. And I also told that last week I'll come up with a scheme of evaluation for you guys. So now there are three components are there, as you are already aware: EC1, EC2, EC3. So EC1 is composite of are combined with multiple elements. One is the quiz component. The second one is the lab assignment or lab hands-on kind of thing. So that's why these timings are also being changed so that you can spend some time in the evening on the lab component, guys. Okay. So it will slowly start maybe from the third, fourth or fifth session, it will start. And we will also help you with what is the expected thing, etc. Like that. So both quiz 1 and quiz 2 are going to be conducted one before the midsem and one after the midsem. Each of them will carry 5% weightage. Okay. Then there will be a cloud lab will be given to you where you are supposed to practice and try to produce the 3 lab worksheets which will carry around 2.5 marks into 3, which is around 7.5%. Then one assignment called as a like lab assignment, which will carry 7.5, which is like similar to the or combination of the 3. And basis this lab assignment and lab worksheets, we will conduct the Viva OCA for you. So what happens is, for example, say today Saturday we are conducting means we will schedule the some Sunday or maybe working days so that convenient for both of us. And at least we will try to spend a group of 5 people will be called and we will spare around 5 minutes so that we ask questions. Based on the questions that you answer, you will be awarded the marks out of 5%. Any questions on this part? Is it clear? Because other two are very standard, so not much of confusion, but only thing is this was the thing, so I made it very clear now. So EC2 closed booklet, EC3 open book, so each of them will carry 30% and 40% respectively, and durations will be 2 hours and 3 hours respectively. Yes, guys, any questions? If you have questions, so that we can spend some time here. Okay. So then we started with the data communication and network management overview started. We discussed about the textbooks, which one to be referred, etc. Then we discussed about the characteristics of the telephone network. So over the telephone network, how the data and information can be communicated. So why it is preferred is because of the characteristics of the data communication, that is delivery, accuracy, timeline, and the jitter. So data communication can happen in three ways. One is simplex, half duplex, and the full duplex. We also discussed the examples about it. So this is a typical telephone network structure. Then the signal to noise ratio is also one of the important thing. And we also discussed about how the calling of Delhi number from Bangalore or different locations that we saw. Then data and telecom networks. So I think I also explained you that the modems were there earlier days over the voice network. So through the modem, you can transfer the data. So there are two types of switchings are there. One is circuit switching, another one is the packet switching. Then LAN and wide area networks are there. So they are connected through the bridges or the routers. So then there is a client server model where client make a request and server will try to fulfill the request. Then TCP/IP based network where internet configuration is also being done. Sir. Sorry, there was a call from another faculty who has requested me for the class change. I have to take that call. Okay. Then we have the various architecture protocols and standards, why they are required, etc. So what we do with that particular thing. Then there is the communication architecture visa with that OSI reference model, all the layers of OSI reference model. The data communication model, I show one simulation for you or video for you so that it was helpful. And TCP/IP things. Then what are the different applications we use? Then comparison of TCP/IP network with the things. Then introduction to the telecommunication network management. So then accounting, then the different trends. So why these technical things are going to be looked at as an engineer, why I'm supposed to do, because a lot of protocols, communication services, which all belongs to us, that is the IT related things. So that is what we saw in the things. So finally, we wrapped up with the help of what we call this. It is called network management functional requirements. We call it as a FCAPS. F stands for fault management, C stands for configuration management, A stands for accounting management, P stands for performance management, and S stands for the security management. So that we saw in the, and some of the standards like IETF, ISO, ITUT, then DMTF. This is what we saw in the last class. Yes, any questions, sir? Somebody has anything to ask? Quickly, please. It's better to discuss each other. Otherwise, it's going to be a. Okay. All right. If you do not have further questions, then we can move on. Okay. So today we start with the second lecture. and we try to continue that particular thing. We talk about, we just saw the introduction part. Today we talk about the like little bit of the physical infrastructures, that is information and network technology related thing. So that we will going to see before we get into the network management aspects. So as you all know, computer network technology consists of nodes and links. Nodes are the computers, links could be the communication channel. Each link will have different modes, etc., that we will discuss going forward. And it could be wired or it could be wireless, fiber optic. So many things are there. So that we will discuss, that is the links. So each of them will have carry certain bandwidth. So based on the bandwidth, we can say the network utilization, throughput, etc. We can calculate basically somehow. So how these nodes and links are going to be configured is what we call it as a topology. The way in which they are connected or interconnected, whatever you can say. That's called as a topology. So broadly, there are two types are there, LAN and WAN. Earlier days, there was in between MAN was also there, called as a metropolitan area network. Now, no more MAN, it's all either LAN or WAN. But within your office, it could be a WAN, not the LAN. But each of the floor or things can be connected through multiple LANs like that. I'll tell you that going forward. Okay. So these types of LANs are just nothing but the Ethernet based LANs or fast Ethernet based LANs, gigabit speed Ethernet, half duplex versus full duplex things. So the way in which you communicate. Then switched Ethernet also. These are physically possible. And there is something called as a virtual LAN, which can be configured. However, the physically you connect, but virtually we can group them and make that as a VLAN. Then there is a token ring, then fiber distributed data interconnection. Either the ATM or the LAN is going to be used. These are the types of LANs which we can discuss. Okay. Anything that I think these are all like, some kind of repetitions or maybe quick recap of what you have studied in the computer networks. I'm sure you have completed the computer communication networks in your earlier semesters. So local area network is what we call it as a LAN, correct? It's a shared medium that serves as a data terminal equipment located in the closed proximity. LAN cannot be like, for kilometers together, but it should be in the close proximity. However, in the historical days, like when these computer networks were in place, there was a longest LAN node or DTE was running for about 64 kilometers. How many kilometers? 64 kilometers. That was the longest existed LAN, data terminal equipment. Okay. So LAN is associated with the three topologies, bus, star, and the ring. LAN is associated with the three topologies, bus, star, and ring. So as you can see here, bus topology is the kind of simplest thing. And there will be a star topology, which will going to have something called the hub connectivity, and they are interconnected. A ring is a little specialized one when compared to these two. They're all going to be in something like, broadcasting kind of thing. It will not be one-on-one kind of things. It will be broadcasted thing. Different protocols are being used in the different topology configurations. Like bus architecture used in the LANs uses the Ethernet protocol. Token ring and FDDI uses the ring topology. And star topology is used in cabling the infrastructures, and ideally hub implementation, we use the star topology. So WANs are configured with either the mesh or tree topology. So mesh is the most common form of internet routing in today's scenario, but still hierarchical. Whenever we wanted, we go for the tree topology also. In case of bus topology, all the devices have equal access to the LAN, because I told you in the mode of transmission is broadcast. Once you go and dump, it will go to all the things. If their IP addresses matches, then they will accept it. Otherwise, the destination address is not same, then they will not accept it. Here we use a randomization algorithm. So that will going to help us to which DT, data terminating equipment, can control the LAN at any given time. That will be decided by the. Then the Ethernet LANs and broadband configurations, as I told you, broadcast networks. So they will be able to use this kind of things. So there is a randomized access, which is called as the CSMA bar CD, stands for carrier sense multiple access with collision detection. If there is a collision happens, so they have to retransmit the data. The most easiest to implement is the bus topology, but lower utilization under heavy traffic, that's up to utilization of around 30 to 40%. That's all. So single culprit could be affecting the entire LAN. One of the faulty thing might affect the entire LAN. That is the problem with this. So this is an example of a ring topology. You can see that now 1 and 4 need to be communicated. Then this is how the token will be passed. So there is a acceptance of the token happens. So once token is accepted, now transmission can happen between the 1 and 4. Okay, like that. That is the things. So this was implemented originally by IBM. That's why it is also famously called as IBM token ring technology topology or LAN. All the devices are connected in the ring fashion with an access to, suppose say 2 can send and receive from 1 and 3, and similarly 5 can receive from 6 and 4, or transmit to 6 and 4, like that. So in order to make it who can actively send, there is a token mechanism is there. Those who are, whichever the station or the data terminal equipment which has got data to be sent, they have to hold the token. Once they are hold the token, others cannot compete for that same time. Now, based upon the destination address, data transmission can happen continuously. Then, once the data transmission completes, then the token will be released. Again, token will be circulated among other nodes. So this yellow color is the indication of the token which is being held, and that violet color indicates that acknowledgement taken, and then the data transmission takes place. Device communicating the holds the token while it's sending and releases the token downstream neighbor when it turns is going to be our data transmission is finished. In case of star topology, it's a centralized management of the network. through the use of a central computer or a hub or a switch we can use for this star topology. So that's why most of the things that you see in your working environment or your office also will have the what we call switches. So it is a kind of star topology where now one of the easiest and add another computer to the network. There will be a 24 port or 48 port switches are there. There you go and connect the things. So cable is already drawn. You can simply, if one computer on the network fails, the rest of the network continues to function normally. So that is the advantage of this when compared to the first one. So star Ethernet hub token ring. That's the hybrid LAN topologies we call it. This is an example of a campus network. Campus network can also be configured like, compared similar to the in lines with your office, right? So that is also called as a campus only. Instead of campus means not like an college or university, but our offices are also like a campus. That's where, for example, say I have not explored much within Wipro, but in our company we have 3 floors. All the 3 floors we have a hub room where the switches are there. Then there is also separate server room, etc. That's where all the things. So each of them, what they have done is they are terminating every floor wise. They are terminating the thing, so that is easy to manage and control. So there is a 10.1.1.0, then 10.1.2.0. That is a 2 separate LANs. So each of these LANs they are going to be connected via bridge, and this is further connected through a router to Ethernet 10.3.1.0. That is another network, or external network, or 10.2.1.0, which is a token ring network, or ATM ELAN, right? 10.4.1. So likewise, we have a different things which are going to be configured basically. Now FDDI is an interconnection of this entire LANs, which is fiber distributed, which is going to be faster than these. So generally, if you take this will be in terms of like LANs are going to be supporting up to generally megabits per second, but sometimes gigabit per second also fast alternative. So this is also FDDI, since it is a fiber channel, so it can support much beyond the things. So wide area networks facilities are media, wired, wireless. There are 2 types of media possible. One is wired mode, or the other one is the wireless. So in case of wired mode, there are multiple options are there like copper, coaxial cables, fiber, etc. Whereas in case of wireless, it is going to be a terrestrial wireless networks, or it could be a satellite communication. Then in the mode, it could be either analog or digital. Analog signals or the digital signals can be used. So services could be plain old telephone services or ISDN integrated services, digital network, or it could be a broadband also. That's the kind of thing that we can see. Okay. To give more things, terrestrial wireless networks where lot of towers are going to be installed. Maybe you might have seen in some public places a very tall pillar kind of thing with a trans receiver adapted or installed on that. And some of the building on top of the building also you could see this. Especially Reliance, Jio, BSNL, Reliance and Jio are one and the same, Airtel, blah, blah, blah. So all these people might have installed this as a thing. Our best example, you can also see, think of that today we call it the air fiber. Air to home kind of thing. So till your house on the building top, it is air media. But from that trans receiver to your modem, it is going to be a what we call fiber. For example, say I will also take a minute to show you this I hope you can see this, right? I have put this 1 minute. I'll remove this effect. Gotcha. Can you see here? I think I have the Airtel modem, correct? So that is Airtel is also through the cable only. So here is the LAN which has come, LAN fiber cable. No, through the LAN it is coming. Okay, this is the cable. I'm sorry. The black one is the cable which is coming from the broadband cable, which is in the form of fiber. Now this fiber is, come and they have used the thin thing. There is a, I think they have installed something called as a, can you see that device? So that will be the device which will go into from the external to the internal, and small this thing through the yellow color cable that given to our modem. So here you can see that it is being connected to the modem. And now from here they have taken to the CCTV camera. So that is the cable. And I have extra spare LAN cable also whenever I feel like I can connect. Otherwise, it will going to work through the wireless only, because I have a what we call, like on the my laptop, I have the wireless, and there is a downstairs one more floor is there for my house. There the signal becomes weak, so that I've asked adopted one more called the repeater kind of thing. Okay, so thus whenever I connect my this thing also, it is possible I can connect a wireless only. You can see, right? I can see Airtel Guru. Two things are there. One is for the what we call the this one nearby one, and another one is a downstairs, which is called as an extender. Okay, like that I have made this arrangement. So now in a way we can also say that I have a LAN here, and wireless connectivity is also there. So a lot of stuff we have done that, because as per the need we have made this changes. Okay, so I'm sure in your house also or in your PG also you might have some kind of pattern similar to this. Any questions so far?
No, sir.
Okay, good. This class will now end at 10:30. Okay. Okay, next class will start 10:45. I will have only 15 minutes break then. Okay, I'm just checking because the next class is there. So that is the terrestrial one, sir. So there is also possibility that from the satellite also transmission can take place in the wireless mode. Okay. So there will be a somebody who receives through that satellite. Maybe ISRO will control that entire thing and transmit to the terrestrial one, and from terrestrial it will be get circulated to the other things. Whereas in case of copper, coaxial fiber, etc., so that same thing is there. But earlier days, before this broadband come or fiber to home, we had something called as a dial-up network, where telephone cable was connected to the modem. This modem, what I showed was broadband based thing. There was earlier days modem which you can be connected through the telephone cable. So from telephone cable, it will go to the nearby this thing, what we call telephone exchange, like I showed in the first day picture, right? So there it will go. Let me show also. So like this line will be connected, then it will go to end office to toll center, etc. See what happens here is telephone network is an analog signal, sir. Whereas our computers DTE, data terminating equipment, will use digital signals. I repeat, computer will use digital, telephone will use analog. So there is a need for modem conversion of data from analog to digital, digital to analog. Vice versa, it was happening. So that's the one way we could use the analog signals rather than the digital signal. Okay. All right. So then we have the band topology, which is called as a like mesh topology or the tree topology, where hierarchical things are going to be used. So mesh topology is implemented in the network layer level, multiple paths between the nodes. This is a very flat topology, redundancy, load balancing, shortest path, all these things are possible. That's why the most commonly used thing is a mesh topology than the tree topology. Wherever that hierarchical things comes, then we go for the tree topology. Otherwise, it's all the one and the same. So this is the Ethernet, which is going to be a LAN transmitting when there is no carrier sensed on the bus. If the collision of frames detected, then device transmitting the frame stops transmission and attempts to transmit again. So this was originally introduced by the Xerox corporations in the 1976. So there are 4 generations: standard Ethernet 10 megabits per second, fast Ethernet 100 megabits per second, then gigabit Ethernets which are going to be 1 Gbps, and 10 gigabit Ethernet which is going to support up to 10 Gbps. That's the generation. So these are the comparisons up to standard one is going to support up to 100 meters. Gigabit can also support up to 100 meters, but with the different media types, you can go for 5000 meter tak. So gigabit Ethernet, which is going to be very fast, can go up to 40 kilometers tak. From 300 meters to 40 kilometers, it can. IEEE 802.3 is what we call it as a final version. Faster is called as a AE, which is the most common one now. So this is the way you connect to the things. Thick coaxial cable or thin coaxial cable can be used, or it could be a twisted pair also. That is ordinary our LAN cable, which will be called as a 10 base T, 10 base 2, 10 base 5, like that. So this is what the communication which is going to be happening, that is through the CSMA bar CD. First they sense that is somebody else is transmitting. If no, then they will transmit. So preamble 8 bytes, destination address 6 bytes, source address 6 bytes, length in the Ethernet bytes is up to 2 bytes. So data may vary from 46 bytes to 1500 bytes, like that. So this data and padding also sometimes possible, along with the destination address and the source address, control information, etc., could be added as a along with the data. Why this data padding is required? Because there is a data length is there. The remaining fields you cannot leave blank, so that's why padding will be used. Okay. So then destination address, source address, the length of the data protocol data unit PDU. CRC, that is the cyclic redundancy code, which will be used for self correction. Sometimes what happens while transmitting, that frame might get damaged. If that is the case, so how it can be overcome, etc., will be discussed as well. Okay. Then we have the bridges to connect the Ethernets. They raise the bandwidth, they separate the collision domains. Smaller the collision domain, probability of collision is reduced very clearly. So you can see that domain without the bridge, but domain with the bridge also. So faster communication if it is going to be a closed group of things. Okay. Now we have the switched Ethernet, which is similar to the bridged LAN. Instead of having 2 to 4 networks, we can have n number of networks, where n is the number of stations on the LAN. Okay. So this is the most common one that we can see in our offices also. So this collision domain is divided into n domains of n port bridge. That I told you, 24 port or 48 port bridges will come. Switches will come. So those could be used to. This is what the example: server at 10 Mbps and clients at server at 100 Mbps and client at 10 Mbps. So switch is there. This is the details with the way they have been connected with the port numbers and the address, IP address. I hope you remember that there is a class A, B, C, D type of thing. That's also. You just take a 1 minute small break. Okay. So this is the details of how the switch will be connected and based on the port numbers 1, 2, 4 like that. So this is the data packets which can be connected as I showed in the other days that your chunks will start attaching the headers that we call it as a Ethernet headers, IP datagram header, TCP segment header, application data headers, etc. will be connected. Thus, the packet looks like preamble, start delimiter, DA, destination address, SCA, source address, time to leave. Then LLC stands for logical link control. It may vary from 3 or 8 bytes. So network data, actual data. So then there is a padding, optional it is. Then FCS, frame check sequencer, that is the CRC. Then end delimiter, which is going to indicate the starting and ending of the packet. Okay. So that is the complete packet format. So VLAN tagged as a packet showing the VLAN header. So preamble, start delimiter, destination address, source address. Now two tags will come. That is the VLAN tags are inserted between the source address and the type of or length field. So where TPID, tag protocol identifier, and tag control information will be inserted if you are using a what we call VLAN. Otherwise, rest of the information is similar to the Ethernet packet. The fast Ethernet is also the same thing. Okay. So then we have a LAN data rate, which is going to be a race. It's going to start from Ethernet 10 megabits per second to 100 megabits per second of FDDI or fast Ethernet or ATM networks, which can give up to 155.52 megabits per second. Okay. So these are the different speed and topology limits that they have. Then what is this VLAN? VLAN is just nothing but a virtual LAN, which is the concept logically the grouping of the nodes or the DTEs is called as a virtual, which will act as a data to layer, data link layer. It will work. VLAN is a local area network configured by the software, not physically. Switched hub enables establishing the virtual LANs. VLANs provide logical isolation instead of the physical segregation. This will also permit you to switch the stations between the LANs without the physical movement of the equipment. So you may go and connect. So most of the time, what happens, you are all carrying the laptops nowadays, right? You go connect. Either you may connect in the 10th floor or in the first floor or in the 12th floor. Doesn't matter. It will get automatically connected. This is how it looks. LAN 1, LAN 2. So they are logically connected, and there is a switches which are being used for that. So in this case, it is divided into the 3 virtual LANs. So each VLAN is a work group area. We can just imagine the group membership in the VLAN is identified by the software. Any station can be logically moved to another VLAN without any disturbance. That again, it can be automatic configuration also or manually also you can configure. So based on the need of your things. So manually when you do, there should be a network administrator who can create that in the software manually, assign the stations numbers, etc. Setup is going to be done. So where the administrator will provide the port numbers and IP addresses or other characters using the VLAN software. Whereas in case of auto configuration, the stations are automatically connected or disconnected from the VLAN using a criteria, whatever is being defined by the admin. Semi-automatic configuration also. So it is usually like manual and automatic are also possible. So you can go and disturb the automatic one and then you can configure yourself. So this is an advantage using the VLAN, and cost and time reduction will also be there. And you can create any number of virtual groups that will also help. Then we have nodes, hubs, bridges, switches, routers, and gateways, which are going to be the nodes. Can be a hub, or it could be a switch, or it could be a bridge, or it could be a router, or it could be a gateway, or it could be a DT, data terminating. So the lower level in the physical layer, you can think of hub. The logical layer, you can think of the switches. And in the network layer, you can think of the routers. Beyond this is called as a gateway. Yeah. So there are the three devices which we can use it to connect. So hub is just nothing but a device that operate only in the physical layer, where signals that carry information within the network can travel in a fixed distance before attenuation endangers the integrity of the data. Means they may be error can be introduced. A repeater receives. A repeater is a thing which will receive the signal before it becomes weak or up to a threshold level. Then afterwards it will be get corrupted. Due to avoid this, we boost the signal. That's called as a repeater. So hub is also act like a repeater. Okay, that's the. So this is a corrupted signal, and this is the regenerated things. So there are two types of hubs are possible: active hub and passive hub. So it is a multi-port network device that amplifies or regenerates the signals as well as the forward the signals. A central connecting device in a network that joins wires from several stations in a star configuration. And sometimes this passive hub does not provide the any processing or regeneration of. The next level is going to be the bridges, where multiple LANs can be connected together to form a single LAN. We use the bridges. Bridge is again similar to switch. It is a layer 2 device. Bridge is also a repeater, and it also can functionally filter based on the MAC address also. Preserve the isolated collisions of the LAN segments, examine the layer 2 destination, and can interconnect different LAN technologies. There are two types of bridges are there. One is transparent bridges and the source routing bridges. So transparent bridges are the bridges in which the stations are completely unaware of the bridge existing. Where it exists, they are not aware. For a source, these bridges routing the operation is performed by the source station, and the frame specifies which route you are supposed to follow. For example, say LAN 1, LAN 2, LAN 3, which are connected by bridge 1, bridge 2, port 1 of B1, port 2 of B1, and similarly port 1 of B2, port 2 of B2. S1, S2, S3, S4, S5 are the stations. So now let us initiate the data transfer from S1 to S5. So what happens? It will from S1, it will go to S5 means that packet will start transmitting to the bridge 1. That is S2 is connected to the the port 1 of the bridge 1 is connected. So that is where it will go to. Then it will enter into the LAN 2. Then afterwards it will enter into the bridge 2. Okay. Then again S1 to S5 data will be transferred, which is on the LAN 3 now. Okay. Suppose you want to transfer from S3 to S2, then this is how the things will happen. So it doesn't know because it's connected to both the bridges. Packet will be sent to B1 as well as B2, and then it will be moved to both the LAN 1 and LAN 3 since they are connected. Suppose say S4 and S3 means it will be sent to only B2, not to B1. This is S2 to S1. That's the kind of simulation what you can see in the text. So you can see that now the movement has been recorded in the bridge 1, bridge 2. If you want further, you wanted to make analysis or some troubleshooting you wanted to do, you can always do so. The switches are again the layer 2 devices, which are high performance multi-interface bridges. A switch is a multi-port bridge with a buffer and a design that can boost its efficiency and performance. Every interface on a switch is a separate collision domain, single broadcast domain, powered and filter frames using the LAN destination address. This can interconnect various LAN and different technologies also. Router is a layer 3 switch also, sometimes we call it, or network layer device, which is going to route the packets based on their IP address. So routers normally connected to the LANs and WANs together via a dynamically updating routing table based on which they can make the decision of transmission of packets. There is a separate collision and broadcast domains are there. They can interconnect the different local area network technologies. So this is how the router, network A, network B. So transport protocol layer, network protocol, data link layer protocol, physical layer things. So this is how the router will communicate to the. So now if you have a router to switches, switches to hub, hub to bridge, or maybe bridges to the other bridge kind of thing. Okay. So this is router is what we call the WAP, wireless access point. So nowadays, okay, in every floor we can see this kind of things. Gateway is a passage to connect two networks together that may work upon different networking models. They basically work as the messenger agents that can take the data from one system, interpret it, and transfer it to another system. Gateways are also called as the protocol converters and can operate at any network layer. Gateways are generally more complex than the switch or a router. Gateway is a router connecting two networks with a dissimilar network protocols. So gateway does the protocol conversion at the network layer. Protocol converter does the conversion at the application layer. So again, gateway is also similar to routers only, but only thing is gateway work on the application level. That is and one more is possible called as a tunneling, which is transmission of data via multi-protocol routers through the encapsulation. Means it will going to encapsulate the entire packet and then it will be sent through the multiple protocols. So is called as a tunneling. So coming to the transmission technologies, as we said, medium is wired or wireless, and mode can be digital and analog. So wired may you have a LAN and WAN, and wireless also LAN, mobile and satellite possible. So physical transport media is UTP, unified twisted pair. Then coaxial cable, fiber cable, terrestrial wireless, satellite transmission are the modes. So there's an example where you could see that LAN cable, which is going to be a category 5 and category 6 are there. When compared to, so generally they will have the, like I think most of you have seen, not to tell, but there are 4 pairs of wires will be there within that thin wires. So that is bundled together and then made. And whenever you wanted multiple connections, you can do the crimping as well, not a problem. So there is a one more thing which comes with a little better shielding. If you want to put it outside the building, then you can go for a category 6. If it is within the building, then category 5 should be good enough. Let us look at some numericals here, guys. Okay. Before that, any questions?
No, sir.
Very good. Okay, we have 1000 megabit per second Ethernet LAN is used to transfer the data between two computers. Between the two computers, the data rate is 1000 Mbps. Frame size is going to be treated at 1500 bytes, and there is an overhead of the Ethernet per frame is around 38 bytes. Ignore the collisions and the retransmissions. Now calculate the effective throughput of the LAN. How much is the speed of the LAN we need to calculate? Thought process, guys. How do you calculate? Please, all of you practice because the numericals are important. The midsem you may expect. The solution is total frame size is 1500 plus overhead is around 38. That many bits into 8 will be around 12,304 bits. And the payload is around 12,000 bits only. Then efficiency is the total frame divided by the total payload will give you the efficiency. Now the efficiency is at 0.975, that is 97.5% is the efficiency. Throughput is equal to bandwidth into efficiency. Throughput is equal to bandwidth into efficiency. Thus, throughput will be 1000 into 0.975, which is equal to 975 megabits per second. That's the calculation. So they asked for a throughput. We have calculated the throughput. Second problem is there is a 1000 Mbps Ethernet, that is a fast Ethernet actually, gigabit Ethernet, which uses a CSMA bar CD for medium access control thing. Data rate is 1000 Mbps. Maximum length of the cable is 20 meters. Signal propagation speed is 2 into 10 to the power of 8 milliseconds meters per second. That's the speed at which it can transmit. Calculate the minimum frame size required to detect the collision. Same thing. Propagation delay you will calculate first, which is just nothing but the distance divided by the propagation speed, which is 200 is the distance, because they have given very clearly 200 is the length. Correct. 2 into 10 to the power of 8 meter per second. That's the transmission propagation speed. So then the delay is coming to around 1 microsecond. If it is 1 microsecond, then you have to calculate for round trip delay, both sending and receiving, which is around 2 microseconds. Then the minimum frame time greater than equal to round trip delay, which is going to be around 2 microseconds only. Now we can calculate the frame size, which is equal to data rate into transmission time. Data rate is going to be 1000 into 10 to the power of 6. That is, they have told 1000 megabits per second. So I have taken it as a 1000 into 10 to the power of 6 into transmission time is 2 into 10 to the power of thing. So that is, sorry, microseconds, right? Transmission time is 2 microseconds now. So 2 into 10 to the power of minus 6, which is coming around 2000 bits. If you convert this 2000 bits into bytes, it comes to around 250 bytes. That is the, so standard frame size will be 64 bytes, but in this case it is 250. The last problem is a 1000 megabits per second Ethernet LAN operates using CSMA bar CD. Channel bandwidth is 1000 megabits per second. Frame size is 1500 bytes. Average number of collisions per frame is equal to 2. Time wasted per collision is going to be 51.2 microseconds. And ignore the delay and protocol overhead at this time. Now you are asked to calculate the effective throughput of the Ethernet LAN. Here frame size is 1500 into 8, which is 12,000 bits. There is no overhead, so you need not to calculate. In the first problem, we saw the overhead of 38 bits. So thus the frame time is equal to 12,000 divided by 1000 into 10 to the power of 6, 1000 Mbps, right? So collision time is equal to 2 into 51.2 microseconds, which is coming around 102.4 microseconds. The time per successful frame is 12 plus 102.4, which is equal to 114. And calculate the throughput. Throughput is equal to useful data divided by the total time, which is 12,000 bits divided by 114.4, which is around approximately 104.86 mega. That's the, yes. Any questions there? Let me stop recording first. Yes.